Hello and welcome to remote learning for Tuesday, 8/25. A couple of reminders that the time zones assignment, which had some technical problems yesterday, will be due Wednesday, 8/26. That will be worth 10 points. It's only 9 questions, so make sure that you get it done. It should be fixed so that you can do it. It's real simple. All you have to do is look at the time zones and see where each American city is and what time zone it is and figure out what time it is. Thursday is our e-learning day. There will be another assignment. That day we will be going over the water cycle, which we will touch on here, and then we will practice more in depth on Thursday. Okay, jumping right into things today, we are doing the forces of Earth notes. So turn to your ISN in the table of contents for number 4 is forces of Earth. So 3 was Earth in space. 4 is forces of Earth. Once you've done that, add a new slide and title it Forces of Earth. Okay, once you've done that, we're going to start going through this. So today we are talking about the forces of Earth. These are both forces on the surface and then forces inside the Earth and how those impact the world that we live on. So we're going to start with forces on Earth's surface. So we have 3 that we are going to talk about: weathering, erosion, and deposition. So weathering is the process that breaks rocks down into tiny pieces, and erosion is the process in which water, ice, or wind remove rock and soil. So these sound very similar, but they're different in one key aspect. Weathering is beating down on a rock and breaking it down into smaller pieces of rock or soil. And erosion is a natural process in which water, like a river, ice, like ice ages, or wind, remove rock and soil and move it somewhere else. So the key difference is weathering breaks something down and erosion breaks it down and moves it somewhere else. So the key difference is the moving during erosion. So you think a river slowly erodes its coastline and moves it somewhere else. Deposition is the process of depositing material eroded and carried by water, ice, or wind. So a river will slowly erode a shoreline and move that soil down towards another area. So we see these 3 processes in a couple of different ways. One is natural weathering and chemical weathering, like acid rain. So chemicals that go up into the clouds and then get rained down on a rock or something will slowly break down that rock or mountain or hill, and sometimes that will erode, and you can see that in rivers. Canyons and valleys are often made from either erosion from a river, like the Grand Canyon is an erosion from a river, and then large valleys are often eroded from something like the ice ages or something similar. At one point, the Appalachians and the Rocky Mountains were similar sized, but due to weathering and erosion, the Appalachians are much smaller now. So the average height of the Appalachian Mountains now on the East Coast is 3,000 feet, while the Rocky Mountains, all 100 peaks of the Rocky Mountains, are over 12,000 feet. So at one point they were somewhat similar in size, and now the average height of the Appalachian Mountains is a quarter of the height of all 100 peaks of the Rocky Mountains. Deposition is moving the eroded soil from like a river or from rainfall that gets pulled down from like a mountain or some sort of landform like that. It gets pulled down, and through this process, it gets moved to somewhere else. So we see this at the ends of rivers often. So one example is the Nile River. The Nile River, it pulls the soil from the long river and deposits it at the end, and it comes off into a bunch of different branches. Another place that we see this, we see it in the United States in the Mississippi River Delta. So New Orleans, at one point about 4,000 years ago, was had very little land, and over time, the rivers just grew and brought out more soil and brought out more soil in a bunch of different waves, and grew what we now have as Louisiana and places like New Orleans, which is why they are so low sea level, because they only bring it out to about sea level, and then the rest washes away into the Gulf of Mexico or whatever sea or ocean it is getting deposited near. So weathering, erosion, and deposition all result in a bunch of different types of landforms, and the four that we are going to talk about are plateau, valley, delta, and plain. Plateau and valley are both caused by weathering and erosion. A plateau is a large, mostly flat area that rises above the surrounding land. And a valley is a stretch of lowland between mountains or hills. Delta and plain are both caused by deposition and the eroded soil coming and laying to rest and stopping in a certain area. So a delta is a flat plain formed on the seabed where a river deposits material over many years. So this is a fertile area or a really wet area near a sea that rivers bring soil that they pull from along their entire riverbed. They pull it all down towards the end, and that forms a area or a landmass that is known as a delta. A plain is a large area of flat or gently rolling land, which is also caused by rivers and streams pulling off soil from larger, higher elevations, pulling it and coming to rest at a certain large opening. Okay, now we're going to talk about forces inside the Earth. So those were forces on the surface of the Earth. These are forces inside the Earth. So first we are going to talk about plate tectonics. This is the theory that explains how huge blocks of Earth's crust called plates move. So a plate is a block of rock or soil that makes up Earth's crust. So a lot of the continents are made up of one continental plate or one plate, and so those move around, and there's the theory of plate tectonics, which is just the explanation for how those huge blocks of Earth's crust called plates move. So you might have heard of something called Pangea, and that was when all of the continents were once one massive landform, and through plate tectonics they slowly moved apart and have come closer to certain other parts and have grown or changed. So as they pull apart, we see something called magma, which is a stream of soft, nearly molten rock that will come as they pull apart. It will come up and form new land underneath the ocean bed, deep down underneath all the ocean. It'll come up and form more land as it pulls apart. So it's not just pulling apart this way, it's pulling apart this way, but then at the very seam, it's rolling up. Faults are the seam in the Earth's crust. So at any 2 points where they meet, that is a fault. So like the San Andreas Fault or the Marianas Trench is another example of a fault. It's a big opening where it's coming out. So if we look at this map, this is a map of the tectonic plates, and we can see on the plate boundaries where they are moving. So for example, if we look in the Indian Ocean, we can see that that seam or that fault, they are moving apart from each other. One towards the African plate is pulling away from the Indian Ocean plate. What you can't see is that it is also moving north. So the Indian plate, where we see most of India at the very northern tip, it's moving north and pushing into this Eurasian plate. And so when we see two plates pushing towards each other, we often see the formation of large mountains. So that is our explanation for the Himalayas, because as they form, you get one plate that will push and come over the other, and that will form a mountain, or they will push up towards each other and form a mountain that way. So we can see that also in South America. In the bottom right corner, we have the Nazca plate and the South American plate, and we can see that those two push towards each other. And if we know about the geography of South America, this far west side of South America is a country called Chile, and that is all mountain ranges. It's a long strip of a lot of mountain ranges all along there. We can see a similar thing up by Alaska in the North American plate where they push together, that all the way going towards Russia and then down towards the Philippine plate. Uh, that entire thing up north, that is a bunch of small mountains and islands and uh, different formations that we can see all along that strip. You see a bunch of tiny little dots. Those are all where they push together and some come up and form. Okay, so we are going to finish today talking about the water cycle. So there are three things that we need to know about the water cycle. But first, we need to define water cycle. So the water cycle is the movement of water from Earth's surface into the atmosphere and then back to the surface. So this happens in a couple of ways. Uh, we need to know about a couple different processes. The first one is evaporation. So that is the process in which liquid changes to a gas. So an example of that would be like boiling water. It gets hot and then it turns from a liquid into steam or a gas or water vapor and rises. We also see this in nature by the hot sun hitting the surface of the ocean, and then the ocean or lake, the surface of that water will evaporate and then rise into the air. We also see condensation, which is the process of water changing from a vapor back into a gas. So water changes from a vapor to a gas in clouds, but we also see this if you're boiling water and you put the lid on, when you lift the lid, there will be water on the lid that will fall off, or you'll notice that there's just water on the lid. So that is water condensing on the lid, or water uh, on like the outside of a bottle, that is condensation on the bottle or your glass. Precipitation is the water falling to the ground as rain, snow, sleet, or hail. And so as it goes into a cloud, it'll get condensed into water in the cloud, and then it'll clump together, and then that clump will fall to the ground in precipitation. So if we look at our water cycle map and we start in the bottom left, we can see that we have some sort of large body of water. So let's say this is just like a sea or the ocean. The sun will beat down on the surface of the water, and the surface of the water will make it hot enough and evaporate and go up into the air. As it rises, it gets cooler and colder, because if you think as you go up a mountain, it gets colder on the top of the mountain. Similarly, it gets colder in the air, and as it gets colder, it turns back into water in a liquid form. That is our clouds. As clouds get bigger and more water condenses, they can get heavier and they start to fall in the form of precipitation. So the water can fall directly back over the ocean or a big body of water, or it can get moved through wind, because if you look at clouds, they're often moving. It can get moved over, let's say, a mountain or just over land, or a smaller body of water like a lake. So as it moves, if it moves over a mountain, it will fall in the form of snow, and that snow will stay on the mountain for a while, but eventually, if it gets warm enough, it will melt, and that is snowmelt runoff. So that snowmelt runoff can either go towards a stream, or it can end in just go onto the soil. So if it goes to a stream, we have what is called surface flow. So it'll run down the mountain and it can run back into a body of water like our ocean or like a lake. So if it runs to the ocean, it just becomes part of the cycle again, and the water is back in the ocean. If it goes to the lake, it's similar in that the sun will beat down on the lake and it will go up into the air as evaporated water again. It can also, if it goes to a lake, it can percolate. So it'll go down into the soil, and as the soil gets so wet, like a sponge, it can only hold so much water. So that is how you get water underneath like a well. It'll just keep going down, 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 and then you can get that where it'll flow back towards the sea and groundwater flow. So it'll percolate down into the water. First, it'll infiltrate the water, so infiltration, and then percolation. As it gets too hydrated, it'll keep going down and form uh, like a bed of water underneath, and that'll flow back towards our large body of water. If it falls just over, if the rain when it falls and precipitates not over a mountain, just over normal land, it can do this same thing, infiltration and percolation, but it could also get picked up by plants. So plant uptake is when a plant takes the water from the ground that falls and it uses it, and then it moves it back out after it's been used in the form of water vapor into the air. So we can see it can rain down over a body of water, over a mountain, and then melt and run off, or it can rain onto land and the land will absorb it and either let a plant use it or send it off back towards our large body of water, and the cycle begins again. And so this keeps on happening over and over and over again. So every bit of water that has ever been a part of the ocean or anything that we have ever drank has all been a part of this water cycle at some point or another. Okay, if you have finished all your notes and you have completed the time zones assignment, we are done for the day. Tomorrow, we will be talking about climates and ecosystems and different different types of climates, the difference between climate and temperature. Reminder again that the time zone assignment is due Wednesday, and Thursday is our e-learning day where we'll have an assignment over the water cycle. So there will be a video about the water cycle going more in depth about what we just talked about, and then there will be a short, I think it's 16 question assignment. It's all very straightforward that if you watch the video and you paid attention today, you should have no problem doing it. Let me know if you have any issues or any problems. I will be in the Zoom chat. If that doesn't work, you can try and message me on Canvas or shoot me an email. I try to respond to those as much as I can, and I try to stay on top of all those pretty pretty consistently. Zoom hasn't normally been an issue like it was yesterday. I think most of it got figured out, but thank you for sticking with us and trying to complete the assignments as much as you can. Thank you to those that shared their ISN with me. If you haven't already, make sure that you do that again so that I have access to make sure that you're staying up to date and you're formatting everything correctly. Okay, have a nice day. I will see you guys tomorrow.